this. You're alone in your bedroom, the lights are off, the curtains drawn, no camera, no lens, no infrared anywhere in the room, and yet somehow your Wi-Fi router knows exactly where you are. It knows if you are standing, sitting, or lying down. It can even estimate the position of your arms and your legs. Sounds like science fiction, right? But in 2022, researchers at the Carnegie Mellon University proved it's possible. They showed that ordinary Wi-Fi signals, the same ones that stream your movies and download your files, can be used to estimate human body posture without a single camera. No images, no video, just radio waves bouncing off your body and being read by an AI. Today, I am going to walk you through how this works, why it matters, and why this research could transform healthcare, smart homes, and perhaps even surveillance. So, most of us think Wi Fi has only one job to deliver internet to our laptops, phones, and smart TVs. But there is something else going on at the same time, completely invisible to us. Every second, your router fills the room with radio waves. And those waves don't just travel in a straight line, they bounce off walls, scatter off furniture, and reshape around your body. Every wall, every chair, every table changes them, and here's the key insight. Your body is one of the strongest reflectors in any room. The moment you move, entire signal pattern shifts. Stand up, sit down, wave your arm. Every movement rewrites the radio waves around you. So your Wi-Fi signal isn't just delivering the internet anymore. It is also collecting an enormous amount of information, data about the room and about everyone inside it. And data is exactly what artificial intelligence loves. So how does a computer understand these invisible reflections? Researchers don't feed raw images to the AI. There are no images to begin with. Instead, they analyze something called channel state information, or CSI. CSI is a detailed fingerprint of how Wi-Fi signals travel through a room, how strong they are, what phase they are in, how they were distorted along the way. Every object in the room changes this fingerprint, and every movement, every step, every gesture leaves its own unique trace inside the data. The problem, CSI is incredibly complex. It's one-dimensional stream of noisy measurements, dozens of numbers arriving hundreds of times per second. No human could ever read it, but modern deep learning models can. They have learned to recognize the patterns hidden inside millions of these measurements and then translate those radio wave fingerprints into something a computer vision model such as YOLO can actually understand. And once you make that translation, this is where things become truly mind-blowing. So we now know that every movement changes Wi-Fi signals, and we know those signals can be captured as channel state information, or CSI. But here's the catch. CSI isn't an image, it's a spreadsheet of numbers, a long list of describing how radio waves travel between antennas. A computer vision model can't read a spreadsheet, it reads images. So how do we bring that gap? The researchers solved it in two steps. Step 1, is called the phase sanitization. Wi-Fi signals are full of interference, reflections, and random distortions. If you feed that maze directly to AI, the model just learns the noise, not the human movement. So first you can clean it. Step 2 is the real breakthrough. A modality translation network, a neural network that takes that one-dimensional cleaned CSI and converts it into a two-dimensional feature map, something a computer vision model can actually process. Just like an image, that single idea translating radio waves into something image-like is what bridges two completely different worlds, the world of radio waves and computer vision. Now comes the breakthrough that gave this research its name. For years, AI researchers have been estimating human pose, detecting where your head, hands, knees, and other joints are. Traditional pose estimation gives you a stick figure, maybe 17 key points, just a few joints connected by lines, useful but limited. Then came the dense pose. Instead of a handful of joints, dense pose maps thousands of points across the entire surface of human body, almost like wrapping a digital skin over you. It's a much richer, much denser representation of the human form. The CMU team asked a wild question. What if we trained a neural network to take Wi-Fi signals as input and produce this dense pose body surface map as output? And here's the trick that made it possible. Transfer learning. They first trained a teacher model using a real camera. That model learned to map the camera images to dense pose. Then they trained a student model that took Wi-Fi signals as input but tried to imitate the teacher's output. The student learned by copying the teacher again and again until eventually it no longer needed visual images. Let's put everything together. The AI works like a production line. Five clean stages, each one handing off to the next. First, your router sends ordinary Wi-Fi waves that fill the room continuously. Second, the antennas measure how those waves bounce, capturing what we call channel state information. Third, that raw data goes through phase sanitization, cleaning up the noise and unstable measurements. Fourth, a translation network converts the one-dimensional Wi-Fi signals into a two-dimensional feature map, something a computer vision model can actually read. And finally, fifth, the system outputs a dense pose estimate, predicting the position of body regions like head, arms, torso, and legs. No photographs, no videos, only radio waves. Five stages from invisible signals to human pose. That's the entire pipeline. And it's this elegant chain of steps that could reshape the future of sensing technology. So at this point, you might be wondering, has Wi-Fi become better than camera? The short answer is no. Camera still produces finer detail and more precise body part recognition. They capture appearance, color, texture, but Wi-Fi does something cameras can't. It works in complete darkness, in smoke, in fog, behind curtains and walls. It doesn't record a single image, no facial recognition, no clothing color, no video of any kind. It measures movement, not appearance. So the question isn't really which is better. They capture fundamentally different kinds of information, but there's a known limitation. Performance drops significantly in unfamiliar room layouts. Furniture, walls, and room geometry. All of it changes how radio waves behave. That's a challenge researchers are actively working to solve. Now let's step beyond the laboratory. Where could Wi-Fi sensing actually go? Imagine an elderly patient falling in a hospital at night. Wi-Fi based sensing detects it instantly without cameras invading every room. Picture a smart home that knows when you have walked into the kitchen, sat on the sofa, or fallen asleep. No camera watching you watching your every move. Think of search and rescue teams using radio signals to find survivors hidden behind collapsed walls where cameras cannot see. The amazing possibilities are real, but so is the terrifying one. The same technology that protects privacy could also be misused if future systems become more accurate. Who controls it? Governments, corporations, or individuals. The real question isn't whether Wi-Fi can see us, it's how we ensure it's used responsibly. The answer belongs to the researchers, regulators, and all of us. So, can Wi-Fi really see you? Without a camera, without a lens, without a single photograph, the answer is yes. Wi-Fi doesn't take photos or videos. It estimates posture, and invisible radio waves carry far more information about the world than we ever imagined. We have walked through how CSI becomes a fingerprint, how face sanitization cleans the signals, how a translation network bridges radio waves, and computer vision, and how DensePose turns it in all into a body region estimates. This is the beginning, not the end. Current limits remain: unfamiliar rooms, limited training data, less accuracy than cameras, but invisible waves carry more information about the world than we ever imagined, and the future points toward full 3D human shape from Wi-Fi signals alone. A journey worth following. Our researchers keep doing the future. If you found this research as fascinating as I did, hit the subscribe, leave a comment, and share it with someone who needs it to see it. Stay curious, stay informed, and keep decoding the future.